All right, welcome to the Explainer. Today, we're diving into something pretty wild: how a mix of AI and a special kind of game theory is flipping security on its head. And it all comes down to this crazy idea that sometimes the best way to win is to actually show your cards. Yeah, it really all boils down to this one central question. How do you outsmart an opponent who's always watching? I mean, think about it. You're trying to defend something important, but your adversary is learning your every move. So what do? Well, the answer is probably not what you'd expect. Okay, so first things first, let's talk about the fundamental problem that security forces everywhere run into. It's what we can call the predictability trap. So picture a typical security patrol, right? Chances are it's pretty routine. It follows a set schedule, a predictable path. Now, a smart adversary, someone who's patient, they just have to sit back and watch. They learn your patterns, figure out your schedule, and then they strike exactly where and when they know you won't be. That routine, that predictability, it's actually a huge weakness. And look, this isn't just some abstract idea. We're talking about real-world, high-stakes situations. This is a massive challenge in everything from preventing border infiltration and tackling urban terrorism to anti-smuggling ops, and even things like ensuring women's safety in vulnerable areas or fighting piracy at sea. In every single one of these scenarios, being predictable is just plain dangerous. So the big question is, how do you get out of that trap? Well, you need a totally new playbook. A kind of defender's gambit, one that flips the whole problem on its head. Now, this is going to sound totally backwards. Why on earth would you ever tell the adversary your strategy? It sounds crazy, I know. But here is the twist. It's not about telling them your specific next move. It's about letting them see your overall method. And trust me, that distinction, it changes everything. And this is where we get into some really cool game theory. It's a concept called a Stackelberg Security Game, or SSG. And here's the core idea, the secret sauce, really. The defender, our side, openly commits to a randomized strategy. So the adversary knows the probabilities. They know you'll patrol target A 60% of the time and target B 40% of the time, for example, but they have no idea which one you're hitting on any given day. This forces them to make their move based on odds, not certainty. You see, this is a total 180 in how we approach security. With the old, predictable patrols, the defender is always on the back foot, just reacting to attacks. But with strategic randomization, you're proactive. You're not just guarding stuff anymore. You're actually shaping the adversary's decision-making process. You're trying to push them, to guide them into making a choice that hurts you the least. Okay, so this all sounds great in theory, but how does it actually play out in the real world? Let's walk through a concrete example and see how the AI comes up with these, well, pretty non-obvious strategies. All right, picture this. We've got an anti-narcotics team. They know there are 3 possible hubs for criminal activity. Let's call them large, medium, and small. The problem is they only have enough people and resources to raid 2 of those 3 hubs in any single operation. And the adversary, they know this, and they're going to pick just one of those hubs to set up shop. So this table here, this is called a payoff matrix. And it's basically how the AI sees the entire problem. It maps out all the possible outcomes for both sides. For example, let's look at that top row. If our team decides to raid the large hub, then the medium hub, and the adversary happens to be at large, boom. Huge win for our team. We'll call it a score of 10. But what if our team makes that exact same move, but the bad guys are actually hiding out at the small hub? Whoops, we miss them completely. Our team gets a 0 and the adversary gets away with it. So the AI's job is to crunch all of these possibilities and find a mix of patrols where the adversary literally has no good move left on the board. So what's your gut feeling here? What would you do? Most of us would probably say, well, duh, defend the large hub the most. It's the most valuable. Makes sense, right? But as you're about to see, our human intuition, it can be a really bad guide in these kinds of complex games. And here it is. This is the answer the AI came up with. And it is absolutely not what you'd guess. So yeah, the plan that includes the large hub gets used the most, about 68% of the time. But look at this. The second most frequent plan is to raid the small and then medium hubs. That's for 28% of the patrols. This isn't just random. This is a very specific, carefully weighted randomness. It's engineered to make every single choice a bad one for the adversary. So, okay, the AI can figure out this perfect kind of weird strategy. That's awesome. But there's another huge hurdle. How do you make this practical for officers in the field who need answers now, not tomorrow? See, the thing is, while the math behind this has been around for a while, actually computing the answer for a complex, real-world scenario has been incredibly slow. We're talking computationally very, very hard. You can't have a team waiting around for hours while a computer spits out today's patrol plan. And for a long time, this was the bottleneck that kept this kind of game theory stuck in research labs. And this is the real breakthrough. Researchers came up with a brand new algorithm that is just worlds faster. I mean, we're talking orders of magnitude faster. You can see it right here. The difference is just staggering. A calculation that was basically impossible to do in a useful time frame is now almost instantaneous. Honestly, this speedup is the whole ballgame. It means security strategies can now be updated in near real time. You get new intel, conditions on the ground change, no problem. You can adapt on the fly. It's what takes this from a cool theory to something you can actually use in the field. And it's not just a concept anymore. It's being put to work across a massive range of security challenges right here in India. We're talking about the Border Security Force using it for dynamic patrols, police forces using it for adaptive beats in our cities, even the Army using it to make their convoy routes safer and less predictable. From anti-drug raids to cybersecurity, the applications are as varied as the threats themselves. So when you put it all together, what does this actually mean for the future of security? Well, it points to a foundation that is just fundamentally smarter. It really all boils down to three key principles. First, be strategically unpredictable. Always keep the adversary guessing. Second, be data-driven. You base your decisions on these powerful models, not just on gut feelings or old habits. And third, and this is crucial, be adversary aware. You have to actively plan around the fact that you're up against an intelligent opponent who is trying to outthink you. You know, the goal of the research team behind this really says it all. Their aim is, and I'm quoting here, to build a foundation for intelligent, data-driven, and adversary-aware patrol planning systems tailored to India's security landscape. This isn't just about theory. It's about building practical tools to meet very real challenges. And that really leaves us with one final big question to chew on. If this way of thinking can completely revolutionize security, where else could we use it? Think about it. From big societal challenges like allocating public health resources to managing environmental protection, what other complex problems could we solve if we just learned to think one step ahead of the game?